Hey everyone, in this video we're going to quickly implement in Python the method to get samples from a multinomial distribution, following the method we saw in the previous video. So the first thing we need to do is to define some variables. For example, the number of experiments. This would be like how many times I roll the dice. So at the end, this is the number of samples we will run. So let's say 5,000. Also, we need to define the number of states of our categorical variable. For now, let's say 6. And now we need to define our vector of probabilities. Let's generate that vector randomly. So let's initially generate randomly a number of counts, and then we will just divide by the sum of all the counts. In that case, we will end up getting a set of random proportions that will add up to 1, which is exactly what we want, to emulate a vector of multinomial probabilities, right? So let's use NumPy. Okay, so here we generate a vector of random numbers, and now we just need to divide by the sum to get random proportions. So our probabilities is going to be the counts divided by the sum. So let's print the probabilities. Okay, let's print the sum. That's almost 1, right? So these are going to be our probabilities, right, for the 6 possible categories we have here. Now we need to define the function that generates the samples, so let's call it categorical samples. This function will need the number of samples we need to get and the probabilities. So let's say number of experiments. We need to do some error checking here. The first thing is to see if the vector of probabilities is correct, meaning that if I sum all the numbers, we get 1, right? Actually, we can have sometimes numbers that are really close to 1, but not exactly 1 because of numerical precision. So let's use the NumPy function called isClose to check that. Then here we must erase the value error. And the other check we must do is that the number of samples is an integer. Actually, let's validate that it's also a positive number. So let's enclose this. We also raise a value error here. Okay, so after doing our quick error checking, we need to start implementing the function. So let's say the first thing, let's calculate the number of states. Basically, it's going to be the size of the probability vector. Now what we need to do is to implement our vector with buckets, from where we will check in which bucket each of the uniform generated samples falls. The easier way to do that is like we construct a vector with the cumulative sum of the probabilities. And after we generate our uniform number, we just check, starting from left to right in the vector of cumulative probabilities, if our random generated number is lower than the number in our vector of cumulative probabilities. So let's call this variable p cumulative, and it's going to sum our probabilities from left to right. So we will start from 0 and then to k, and we will be increasing k by 1. Okay, so for example, the first element in this vector is going to contain the first element of our probabilities vector, right? Because when k is 1, this will be 0 and 1 here, meaning that this will capture one element starting from position 0. So the sum of that is going to be just that element. When k is 2, this is going to capture the first two elements of our vector of probabilities and add them up. And at the end, when k is the number of states, this will capture all the elements of the array and add them up, so we will get 1 in the last position. Please pause the video and make sure that you understand what this line is doing. Okay, now we need to create a variable with the counts of the samples, which is actually the variable that we will return. So we can use a dictionary for that. Let's call it counts. So this will be k and 0. We will initialize all of them in 0, right? Range, number of states. Let's create the random uniform samples. Here we have uniform samples between 0 and 1. And now we need to go over each of the samples and check where it's falling and then increase the count of that state. Okay, so here we are adding an index to this vector of cumulated probabilities to use it to find the key in our dictionary. So here we check if the sample is lower than the value. Remember, we are going from left to right here, checking every cumulated probability in our vector, and whenever we find that the number is smaller than that limit, we increase that bucket in 1. So our counts of index is going to be increased in 1. So after we find this, then we don't need to continue iterating in this inner loop. So we can break it and we return the counts. So that's our function. So let's try it. Let's say that we will generate some samples. For here, we will use our predefined variables that we have up here, the number of experiments and the probabilities. Okay, so let's check if these numbers make sense. So what we can do here is like we can print first our multinomial probabilities. And then we can print our sample counts divided by the total. And those proportions should be close to our initial probabilities, right? So we will need the sample counts, just the values. So we need to convert this to a list before converting it into a NumPy array. Let's make sure that this is a float type. So we can now divide by the number of experiments, right? Let's print that. Okay, here we go. So let's check. The first number is, okay, close. Second is also close, 0.24. The third's 14. The fourth, yeah, it seems to be working. The other thing we can do is to plot this with bars. So let's use matplotlib for that, and let's use the bar plots. So here we will plot the keys, the values of the dictionary as the size of the bar, the keys as the name or categories, an orange color. So let's decrease the width a little bit. Sorry, 0.5. And now let's compare this plot to a plot of samples obtained by using the NumPy function. We know that this function is already included in NumPy, but for learning purposes, we saw how to actually implement it. So let's say that now we have other samples that are going to be numpy.random.multinomial with our same variables, the number of experiments and our probabilities. So here we're getting samples using the NumPy method, and we should get mostly the same bar plot. So let's use our keys for names of the categories, but now let's use the other samples instead of our samples. This time let's use color. Okay, so we run this and this is the result. So we can see that this is mostly the same plot by using NumPy samples. So we, just to check, let's run this again with another vector of probabilities. Here we got a new vector, right? And let's generate another set of samples. So this is our new plot. And let's do the same here with NumPy, and we can see that it's mostly the same plot. So that's it. If in real life you need categorical samples, you just use NumPy function. But again, it's good to learn and understand what's going on behind the scenes. So that's why I show you one alternative to implement this function ourselves.